NASA is about to launch the most advanced laser instrument of its kind. The Ice Cloud and Land Elevation Satellite 2, or ICESat-2, will measure changes in glaciers, ice sheets, and sea ice. So, to prepare for launch, we're counting down 10 quick facts about ICESat-2. 10,000. That's how many times the ICESat-2 laser will fire each second. More pulses mean more height data. The fast-firing laser will allow us to measure the average annual change in the vast ice sheets down to the width of a pencil. 9 years of data from Operation Icebridge will be added to ICESat-2's new data. The airborne mission bridged the gap between the original ICESat and ICESat-2 with flights over the Arctic and Antarctica. 800 picoseconds, less than 1 billionth of a second. That's the precision at which individual laser photons will be timed as they complete their round-trip journey from the satellite to the Earth and back. 7 kilometers per second is how fast ICESat-2 will zoom above the planet. It'll complete an orbit around Earth in 90 minutes. The orbits will converge around the poles, focusing the data in the regions with the most expected change. 6 laser beams split from 1 on board ICESat-2. That's 6 times the beams of the original ICESat. More beams will cover more ground, or ice, and allow scientists to assess the slope of the surface they're measuring. 532 nanometers, the wavelength of the bright green laser. When these laser photons return to the satellite, filters block any light that's not exactly at this wavelength, keeping the amount of data noise down. 4 times a year, every 91 days, ICESat-2 will measure the same ground tracks, allowing scientists to see how glaciers and other frozen features change with the seasons, including over winter. A 3D look at Earth, now with more height. ICESat-2 will measure elevation to see how much glaciers, sea ice, and ice sheets are rising or falling, and give us a more complete picture of our planet. There are 2 types of ice that ICESat-2 is after: land ice and sea ice. Land ice builds up year after year from snowfall, but sea ice forms when the ocean water freezes. It can last for years or just one winter. Only one instrument, but it's a really good one. The Advanced Topographic Laser Altimeter System, or ATLAS, was built by hundreds of people at NASA's Goddard Space Flight Center to exacting requirements so that scientists, very soon, can measure minute changes in our planet's ice.